Hey guys, how's it going? It's Ariel. I am just wanting to make a video regarding discrete distributions. I know some of you are struggling and I wanted to help out in any way I can to help you succeed. I know some of you are a little too busy. You might be full-time students, too busy to come in to tutoring hours. And I just wanted to make this for you so that you do get the help that you need without having to skip your classes and come into tutoring. So let's talk about distributions. We've got two kinds that we went over today in class. We've got Poisson distribution and we've got discrete binomial distribution. So with the Poisson distribution, this one's going to be your easiest distribution, Poisson. The equation for Poisson distribution is defined as P of x, or the probability of x happening, equals lambda to the power of x times e to the negative lambda all over x factorial. There. Alright, so let's talk about these symbols in this equation. I know it can look a little bit intimidating. Let's start off with lambda because I feel that it's the most important one in here. Lambda is defined as the mean or the average number of times something happens in a given period of time. So average number in a given time. When you're thinking about time, I don't want you to just think about, minutes or seconds or hours. You should be thinking about days and weeks and months and years or half moons, any sort of a relation to time. So what we're going to do now is look at this e to the negative lambda. E is going to be a function on your calculator. And it should say something on the button, and I'm sure you'll have to press second and then another button, but it should say something like e to the power of x. There should be a button that says this right here. And that's what that e is. I know some students came in today a little bit confused about that portion. X in this equation is going to be where we plug in the variables that they're asking for. So x is going to be interchangeable. Alright. So I'm going to give you a second to write this down or pause the video because I'm going to move on over here so that I can actually go through a problem with you guys and show you how this works out. Okay. So, if you go to page 147 in your books, you'll see example 5.13. We're just going to work through that one together. So it says, on average, 4 children are born daily at a local maternity in Heathsville, excuse me. So when I'm looking at that, I'm trying to look through the problem, and you should get into the habit of doing this, to looking into the problem and seeing what information you think is important. So in the fine print there it says, on average, 4 children are born daily. On average. Those are the words that you want to look for. And if you remember, we define lambda as the average. If you're looking at a problem and you're wondering if this is Poisson distribution, another thing I want you to pay attention to is it gives you the average number of things happening in that given period of time. So here it's giving us, on average, 4 children are born daily. Daily is our unit of time. So we're going to say that our lambda equals 4 in this problem. So now what I can do is I can come down here and say, okay, if lambda equals 4, I can plug that into my equation. I can say P of x equals lambda, where I'm putting 4, to the power of x times e to the negative lambda, which is 4, all over x factorial. So let's try to solve this now. Let's go to I. It says, what is the probability that no more than 2 children would be born? No more than 2. So when you're thinking about that, you have to think of what no more than 2 means. And what no more than 2 means to me is that, okay, I can have 0 children born on the unit, I can have 1 child born on the unit that day, or I can have 2. But it's concerned about no more than 2. So I can't go over 2 because they don't care about that. They're just wondering about 0, 1, and 2. So now when I'm given these values, I see students getting a little bit confused as to how to use these. I want you to remember that each of these given values is an x value. Remember in the beginning where I said that x's are interchangeable. So we can take one of these, let's say that we're going to take 0, and we can say, okay, 0, I'm going to take you over here and plug you in to all of the x's. And then when I'm done with 0, I can say, okay, 1. I'm going to take 1 and I'm going to plug it in to all of the x's. And I can keep on doing that until I've exhausted all of the ones that I care about for my probabilities. So with that in mind, I'm going to come down here, make sure that I have enough space. I feel like I'm using up a lot of room. So we had our equation, P of x equals lambda, or 4 in this scenario, to the power of x times e to the power of negative 4, or lambda, all over x factorial. And what the problem gave us was that we were to solve for 0, 1, and 2. It was looking for the probability that no more than 2 children are born on the unit in that day. And I said that we can take the 0 and say, okay, P of x equals 4 to the 0 times e to the negative 4. That 0's here because it's an x value. I can plug it in for x. Divided by 0 factorial. One thing I want you guys to remember is 0 factorial is always going to be 1. I know in your calculators, if you try it, it's going to say it's 0. It's always going to be 1 because we cannot divide by 0. The equation is undefined. It's just null and void if we try to divide by 0. It doesn't work out for us. So I can evaluate it. I can say, okay, 4 to the power of 0 is 1 times e to the negative 4 is going to be 0.018316, and I'm dividing all of this by 1. So really, I can cancel out the 1s and say that this equals 0.018316. Let me just went through the first one. So now we're going to do the second one. We're going to say, okay, p of x equals 4 to the power of 1. I took the 0 out and I just put that 1 right there, times e to the negative 4. And notice that 4 isn't changing. When I do this, I can take out x's and I can plug in x's, but lambda has to stay firm. Lambda doesn't change. This is all over 1 factorial. So when I go through and I do the math here, I get 0.073263. I'm not actually doing the math. I'm not that quick at math. I'm just going through with the book, so I'm trying to explain it to you guys a little bit better than it does in the book, though. So now we're going to take 1 out, and we're going to say, okay, let's do the last one, p of x, because we still have to do 2. P of x equals 4 to the power of 2 times e to the power of negative 4 all over 2 factorial. And if it helps you guys to put parentheses in these so you know what order it is, this bad boy gets done by itself, this bad boy gets done by itself, and then we can multiply them both together, and then this bad boy gets done by itself, and then we can divide. So when I'm done with this, I get 0.146525. But how do I know what to do with all of these probabilities that I got? Because I have 3 probabilities. I have the probability of 0 being born on the unit, I have the probability of 1 being born, and I have the probability of 2 being born. And I want to know what to do. One thing that I want you guys to remember, and we're going to come over here so I can write down this rule. One thing I want you guys to remember is wording in statistics is very, very important. So when you see the word and I want you guys to remember that that means multiplication. And if you see the word or, I want you to remember that means addition. Now let's go back to our data. If I can get there. And I want to look at this as I can either have 0 babies born on the unit in a day, or I can have 1 born a day, or I can have 2 born a day. But I can't have 0 and 1 and 2 born on the same day. So what I want to do is take that or and say, okay, or means addition. So I'm going to take these probabilities and I'm going to add. I'm going to say, okay, 0.018 plus 0.073 plus 0.146525. And when I'm done adding all of those, my final answer is going to be 0.238103. What this means is that there's a 0.238 probability that 0 or 1 or 2 babies are going to be born on the unit in one day. And when you're thinking to yourself, gosh, I don't know if this is right, that's a really low probability, one thing that you can remember is that our average or our mean was 4. And then 0 and 1 and 2 are substantially lower than 4. So So it makes sense that our probability is low because there's not a very high probability that the number of babies born is going to be that much lower than the mean babies born on the unit. This is just a walkthrough on Poisson distribution. In my next video, I'll go through binomial distribution. Hopefully this was helpful for you guys. If you do have any questions, you can stop by my tutoring hours and let me know, or shoot me an email. You can also email Sarah or Claire or Shook Yang, and we're all here to help you guys. Thanks and have a good night.